Hey guys, we're going to go ahead and get started with the next section. This section is about inductive reasoning. So our objective is I can use inductive reasoning to make conjectures about patterns and relationships. Okay, so basically inductive reasoning just means it's your thinking process. Like based on the examples, you're able to reason and come up with a conjecture or basically just a good guess as to what the pattern is that's happening. So it's going to be all about recognizing patterns and relationships and things. So inductive reasoning is a type of reasoning that reaches conclusions based on patterns. So you're using patterns and you're trying to figure out the pattern in a situation so you can continue solving further. So if you look at number one, it says if the pattern were extended to 5 rows, how many circles will there be total? So if you look over here at this figure, we have 1, then 2, then 3, then 4 circles. So if I were to extend this pattern, in the 5th row, there will be 1, 2, 3, 4, 5 circles. So if I were to continue this pattern, there will be 5 circles more in the 5th row. So it says how many circles will there be total? Well, there's 1 here, plus 2, plus 3, plus 4, plus 5. So I would just add those all together. 5 plus 4 is 9, plus 3 is 12, 13, 14. There would be 15 circles. Okay. The next question says, how many circles will there be in row 10? So if you kind of noticed as I was labeling these, I started down here at the bottom and I said, I'm going to call this row 1 has 1 circle. Row 2 has 2 circles. Row 3 has 3 circles. Row 4 has 4 circles. So that's how I knew there would be 5 circles in the 5th row. So if I were to continue this pattern, the 6th row would have 6 circles, the 7th row would have 7 circles, and so on. So in the 10th row, we would have 10 circles. So that was inductive reasoning. I was just kind of looking at the figure or the pattern to see what was happening. Okay, so you might see some examples where you're dealing with patterns of shapes and things like that. A more common type of problem you're going to see is just going to be this type right here, where you're just guessing the next 2 terms in a sequence, or a sequence is just a pattern of numbers. Okay, so we have 88, 82, 76, 70, 64. So if you look at these numbers, we want to figure out the pattern here of what's going on. Well, we know that they're decreasing. So in order to go from 88 to make my number smaller, I either have to subtract or I have to divide. That's the only way you can take a number and make it smaller is by subtracting or dividing. So if I go from 88 to 82, 88, if I would subtract 6, that would give me 82. Okay, so let's see if that works for me to continue. If I do 82 minus 6, does that give me 76? Yes, it does. I could type that in my calculator just to check. And then if I do 76 minus 6 again, do I get 70? Yes, I do. And if I do 70 minus 6, do I get 64? Yes, I do. So because this pattern works every time, I know the pattern here. So my pattern is going to be to subtract 6 every time, but that's going to help me to figure out these next 2 terms. So if I want the next number, I'm just going to subtract 6 again. So 64 minus 6 is going to give me 58. And the next number, I would do 58 minus 6 again. That's going to give me 52. So inductive reasoning is just recognizing a pattern in order to either continue that pattern or answer a specific question. All right, so same thing here. It says use inductive reasoning to determine the next 2 terms. Well, if I look at this, my numbers are getting bigger. 3, 5, 9, 15, those are all getting bigger. So again, the only way to get bigger would be to add or multiply. Well, if I multiply 3 times any number, 3 times 1 is 3, but 3 times 2 would give me a 6, and that's too big, so it's not going to be multiplication here. So let's see what adding does. So 3 plus 2 would give me a 5. All right, well, 5 plus 2 does not give me 9. That would give me 7. So 5 plus 4 is going to give me a 9. And then if I want to do 9 to 15, I would have to add 6. And then if I want to do 15 to 23, I would have to add 8. So if you notice what we're adding even numbers. We had 2, then 4, then 6, then 8. So the next number that we would add would be 10. So 23 plus 10 will give me 33. So then the next even number after 10 would be 12. So 33 plus 12 would give me 45. All right. So what I want you to do is I want you to pause the video and I want you to see if you can answer question 4. It's the same idea. Want to continue this pattern. So go ahead and pause the video. And when you're done, go ahead and hit play and see if you got it correct. All right, so hopefully you were able to come up with those next two numbers there. The pattern to go from 800 to 400 was dividing by 2. So if you divide by 2 each time, you will get the next term. So 100 divided by 2 is 50. Divide by 2 again, you get 25. Go ahead and see if you could do number 5. It's the same type of thing. Here we're talking about a chess club, and then each year how many members are in it. So based on the data, about how many members would you expect the chess club to have in year 5? So again, pause the video and see if you can come up with how many people will be in the chess club the following year after year 4. So hopefully you were able to come up with the pattern here. Each time you were adding one more, so each year you added one more new member. So to get the 5th year, you would have added 6 new members. So 22 plus 6 gives you 28. All right, so the second part of this lesson focuses on examples and counterexamples. So it says find a counterexample to show a conjecture is false. So basically, a counterexample proves a conjecture or an educated guess. Remember, conjecture just means educated guess to be wrong. Okay. So a counterexample is going to say, let's say the pattern is adding 5 every time. Well, you would just have to show that that pattern of adding 5 doesn't actually work every time. Okay. So this says a polygon has 2 fewer diagonals than its number of sides. Okay. So if you look at this first polygon, this is actually a square. It has 4 sides. And if I were to draw a diagonal, remember that just means you go to the opposite vertex. So there's one diagonal. And then if I do the other side, it would be 2 diagonals. So it has 4 sides and 2 diagonals. Okay. So it says a polygon has 2 fewer diagonals than the number of sides. So if it has 4 sides, 2 fewer than that means it would have 2 diagonals. So for this conjecture, this example works. So this would be an example that worked. Okay, so this is called an example. It says the polygon has 2 fewer diagonals than the number of sides. Here's a picture. It has 4 sides, 2 diagonals, so that example came out to be true. So let's take a look at the next one. If I have 5 sides, it should have 3 diagonals because our conjecture says it should have 2 fewer diagonals than sides. So if I have 5 sides, I want to only have 3 diagonals. So to draw a diagonal, remember you start at a vertex and you can go to an opposite vertex that's not right next to it. So I could go from here to these 2 vertex or vertices because they are not right next to it. But I could also go from this vertex to this vertex. I could go straight across. I could go from this corner to this corner. So I have 1, 2, 3, 4, 5 sides and 5 diagonals. So that means this does not prove our conjecture to be true. So we would call this a counter example because it was only supposed to have 3 diagonals and we ended up coming up with 5. So this would be an example of what a counter example is for this problem. Okay, so for this last one, it says, can you find 4 examples that are true or a counterexample for the following statement? It says, for every integer n, the value of n squared plus 1 is always odd. So that means for any number I pick, if I square it and then add 1, it should always be odd. So let's just do some examples. So I'm going to try 0. I'm going to do 0 squared. I'm just plugging in for n here, plus 1. Well, 0 squared means 0 times 0, which is 0, plus 1. Well, 0 plus 1 is 1, and 1 is an odd number. That worked. That turned out to be true. Let's try it again. Let's try 1. I'm going to do 1 squared plus 1. Well, 1 squared is 1. 1 times 1 is 1. And then if I add 1, 1 plus 1 is 2. Did that come out to be odd? No. So this would be a counter example. So the question said, can you find 4 examples that are true? So see if you can come up with 3 more examples. So my first one here, this is an example. My second one here, this is a counterexample because it came out to be even, which would make it not true. But see if you can plug in any other numbers. You want to come up with 3 more examples that work. If you square the number, add 1, it'll be odd. So go ahead and give that a shot. See if you can come up with 3 more. And then pause the video while you do that, and then hit play to see if you came up with some of the same ones that I did. Hopefully you were able to come up with some of these examples here. If I plug in 2, I get 5, which is odd. If I plug in 4, I get 17. And if I plug in 6, I got 37. So basically, anytime you plug in an even number and add 1, it'll turn odd. So if you plugged in 3, 3 is not going to work. It's going to give you an even number as your outcome. So that would be another counter example. Okay. So go ahead and you can take a shot at start working on the homework. Please make sure you are asking questions in class this week. We'll have tons of time in class to answer questions. So that'll be, there should be no reason that we don't do very well on this section. I will see you in class.